Hi, fourth graders. This is Miss Kovarik, and I am here with your Monday Science Lesson 24. Um, we are going to be learning about energy this week, and energy means a lot of different things. So today we're going to introduce it, and tomorrow we'll talk about all the different individual types of energy that there are in the world. All right. So ultimately, energy equals power. And as you look in this picture, you can see a lot of different types of power. This could be powering really big machines. This could be powering something to roll down a hill. This goes on a really wide spectrum. So when you hear the word energy, you should be thinking about the smallest things all the way up to the biggest things. Energy cannot be created. So you can't just say, I'm going to create some energy to fuel my house with. It doesn't work like that. They need to get coal. They need to use wind. They need to use sunlight. We need to get the energy from somewhere because you can't just create energy. It also can't be destroyed. If you have energy in something, you can't just get rid of it. It either stays where it is or it needs to go somewhere else. So when we are taking energy from the sunlight to allow plants to make food, when we are taking energy from wind to allow wind turbines to make electricity, we are not getting rid of the energy. We are just putting it from one place to another. So energy can't be created and it can't be destroyed. And also, you should be thinking of the food chain when we talk about energy, because those arrows in the food chain were telling us how food and energy was passed on. So the energy from the plant moved to the bird. The energy from the bird moved to the rabbit. I don't think rabbits eat birds. Okay, the energy from the bird moved to the... What's something that eats birds? Raccoon. I don't know. Then the energy from the raccoon moved to the eagle. The energy is flowing. The animal has the energy in its body and it's going to another animal as it consumes it. Sorry, guys. Some examples of energy. So when you plug something into an outlet, when you charge your phone, when you turn on a lamp, when you turn on the TV, anytime you are plugging something in using electricity, using batteries, that's a form of energy. Putting gasoline in a car to make it run, that gas is acting as energy for that automobile. The sunlight provides energy for plants to make food. The wind provides energy. If you've seen those really big wind turbines, we'll talk more about tomorrow. Those are collecting the energy from the wind and putting it somewhere else, like to heat our homes or to turn our electricity on. And also, you have energy. Not only do you use energy when you are doing things, but you also eat to get energy. So we get our energy from the food that we eat, and we use energy when we do different types of activities. So like when you pick something heavy up, when you jog for PE class, when you're writing a story, any type of movement or stuff like that, that's all using energy that we have in our body. Okay, so I'm going to read a short excerpt from an article on energy. These articles will have a lot of information that you need for your Google form. Sorry, my guinea pigs are being naughty. So make sure that you reread the passage if you need to, and you can even pause this video and go answer the questions as I read, up to you. So this first section is called Atoms and Energy. Energy is everywhere because it comes from atoms. Everything in the universe is made of atoms. When two or more atoms join together, they form a molecule. Water molecules, for example, contain 2 atoms of hydrogen and 1 atom of oxygen. So atoms are really, really, really small little things that contain energy. When 2 or more of these come together, so 2 or more of these little, they're not molecules, they're like particles that have energy in them. And we're going to look closer at them in the next picture. When they come together, so we have all these different types of atoms in the world. Hydrogen and oxygen forms water. So when two hydrogen atoms and one oxygen atom come together, they form a water molecule. And molecules are also really tiny, but remember, atoms are smaller because atoms make up molecules. Inside of atoms, there's tiny little things called protons, neutrons, and electrons. And I'm going to show you a picture of what this looks like. The protons and neutrons are in the middle, and the middle of our atom is going to be called the nucleus. So we have the nucleus, we have protons and neutrons on the inside, and then on the outside of the atom, we have the electrons. Let me show you the picture real quick. So here's the neutron, the green on the inside. The protons are on the inside as well, and the electrons are on the outside. Okay? The reason why electrons are on the outside is because they have a negative electric charge. So like when you look at a battery and one side says negative and one side says positive, things can either have a positive charge or a negative charge. And that determines what it's attracted to and what kind of energy it has. So electrons have a negative electric charge. Protons have a positive electric charge. That is why electrons and protons are attracted to one another. This attraction is what holds atoms and molecules together. Sometimes electrons move away from an atom. When they do, they can become attracted and join up with protons on another atom. There is a lot of energy inside each tiny atom. Scientists believe if they could release all the energy inside the atoms of 2 pounds of coal, they could power a whole country for weeks. So just to summarize that, the reason why that atom is an atom is because the positive and negative charges are attracted to each other. Think about a magnet. When you put a positive and negative side of a magnet together, they stick together quickly. When you put a positive and a positive, they will repel each other. They'll push each other apart. So positives are attracted to negatives and vice versa. Also, inside that teeny tiny atom, there is a lot of energy. If they could release all the energy inside 2 pounds of coal, they could power a country for weeks, and that's a lot of energy. So picture again, one more time. So again, the electrons are on the outside. We've got neutrons and protons inside the nucleus. All right, so there are 2 types of energy that we're going to talk about today. We have potential energy for the first one. And when somebody has potential, that means that they can do really great things, but they're not really doing anything at the moment. So potential energy. A lump of coal may not look like it is full of energy. You can't see the atoms moving in the coal. The energy they have is just sitting there. This is called potential energy. But we need something to act on the coal, such as fire, in order to use the energy. When coal burns, it releases energy. So just a lump of coal sitting there. Even though it has energy inside of it, it has atoms inside of it, it's not doing anything. It's not giving off its energy, it's just sitting there. Once you add fire to that coal, however, it's now able to release the energy, and we're able to use that to power our homes and keep our houses warm in the wintertime, turn on our electricity. It gives us the energy to do that because we combined it with the fire. If we didn't combine it with fire, then it would just be potential. It wouldn't be kinetic, which is the next word. And kinetic energy is energy that is in motion. So energy that is being used, energy that is shown. So a ball that is sitting on the ground in your backyard has potential energy. It isn't moving, but if you throw it, it now has kinetic energy because it's moving through the air. So it's just sitting there. That would be potential. You pick the ball up and throw it. Now it's kinetic. It's moving. It's giving off energy. A rubber band has potential energy. When you hold it and stretch it, it has kinetic energy. When it is moving through the air after you let it go. So right here, I'm just holding it. I'm not doing anything with it. That's potential. The second I let it go and it snaps, it's now kinetic. All right, I think that's it. I've got a little picture here to help you understand that as well. So as the bike is just sitting here, it's kinetic. I'm sorry, as it's just sitting here, it would be potential. As he starts going up this hill, he's taking in energy. That would be kinetic energy. He is moving. He is taking the energy in. Now he's up here at the top of the hill. He's not moving. That's potential energy. The second he starts going down this hill, that's more energy out, and that is kinetic energy. All right? If you have any questions on that, make sure to come on my Zoom hours. I'm on Zoom every day from 2 to 4, or your teachers can help you out as well. All right, let's go over this really quickly, and then I will let you go. So this is all of the readings that I just did. They're there for you to quickly go back and look, and you can also use the slideshow. Number 1, energy can be destroyed. True or false? Number 2, which is not an example of using energy? Driving a truck, eating a piece of fruit, sitting on the couch, or turning on a lamp. Number 3, what provides energy for plants to make foods? Number 4, what are atoms? Is it a spark of electricity? Something small that makes up everything with energy? Something the wind picks up? Or something you plug cords into to get electricity? 5, when 2 or more atoms join together, they form a blank. Fill in the blank. 6, which is not found inside the middle of the atom. Nucleus, proton, neutron, or electron. Use that picture or use the reading. 7, true or false, there is a lot of energy inside an atom. And 8, a ball sitting at the top of a hill is an example of potential or kinetic energy. Okay, I hope you guys have a great Monday, and we will see you tomorrow morning. Bye, Adams.